Hello once again, everybody. I'm meteorologist Sean Sublette, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has print and digital operations in more than 70 locations across the country, including in my home base in Richmond, Virginia. I'm joined by my colleagues from Across the Sky, Matt Holiner in Chicago and Joe Martucci at the Jersey Shore. Kirsten is out this week. Our very special guest this week is Dr. Michael Mann, director of the University of Pennsylvania Center for Science, Sustainability, and the Media, and the Presidential Distinguished Professor of Earth and Environmental Science. His latest book came out a couple of weeks ago called Our Fragile Moment. It goes through Earth's climate history to illustrate how we know what the current warming climate is without precedent in Earth's history. There is so much good stuff in this book. I could go on and on, but I really like the way he goes into paleoclimate and helping us understand why we are at this moment in time and why he calls it our fragile moment. And as a quick aside, in the book, he kind of alludes to the Police, the band, the Police, and the extinction of the dinosaurs and walking in your footsteps. So those of us of a certain age who remember that, a good part of that. But, Sting was the lead man of the Police. And Fragile was another song that Sting wrote. So this all kind of ties back into me. Here I am showing my age. But guys, this is such a great conversation. What did you kind of take out of this show?
Well, I think, and just take a step back. I mean, Mike Mann is, I would say, one of the people who really put climate science on the map to the general public. So this is really a big interview that we have here. And when you're listening, we really, sometimes we're getting into the weeds. Sometimes it's big philosophical questions. In fact, at the end, we can talk about, his thoughts on where our position as the human race is in the universe just by writing this book. So it was a nice interview and good to be with Mike here.
Yeah, that's the thing. There are few people that are a bigger expert on climate change than Mike Mann. And so, yeah, we're honored to have him on the podcast. And what I like is how he talks about paleoclimate, which is something that's starting to get a little bit of buzz now. I think everybody's accepted that, okay, the climate is changing now, but hasn't it changed in the past? And he does dive into that. Yes, it has changed. But what he points out is what's the change that we're undergoing right now is unique, and he points out why that is. And I really liked his discussion of that.
Yeah, there is so much good stuff. So let's get right to it and start with our interview with Dr. Michael Mann. Mike Mann, it is so good to have you on the Across the Sky podcast. I want to jump right into this on this book, Our Fragile Moment. This is the 6th book. What I loved about this one is that it goes a lot deeper into understanding paleoclimatology. For us real science geeks out there, it really gets into depth about how we know how we got to this fragile moment. So I wanted to start in the big picture. What motivated you to write this book now?
Yeah, thanks, Sean. It's great to be with all of you, all three of you. And, it's interesting. This is sort of where I got my start as a climate scientist. Paleoclimate, the hockey stick curve that my co-authors and I published. It's hard to believe now, but it's 2.5 decades ago. That graph became sort of this iconic symbol in the climate change debate. And that's really how I sort of entered the fray. And so now, 2.5 decades later, I decided, well, let's do a deeper dive, because the hockey stick only went back 1,000 years. That's really shallow time, as we say in paleoclimate. We've got 4+ billion years of Earth history to look at, and let's see what we can learn from it. And so it's sort of a return to my roots, in a sense. I hadn't really written a book about paleoclimate, even though it's, where I started as a scientist. And there's another sort of driving force here as well, which relates to my last book, The New Climate War, which is about sort of the challenges we face now as climate denial becomes almost untenable, because we can all sort of see the impacts of climate change playing out. But there are other tactics that, bad actors are using to sort of delay the transition off fossil fuels. And one of them, ironically, is doom mongering. If they can convince us that it's too late to do anything about the problem, then why bother? And so I was seeing paleoclimate, something that I hold dear, I was seeing paleoclimate science weaponized now in the same way that climate deniers used to weaponize misinformation. I was seeing climate doomers weaponizing misinformation about paleoclimate to convince us it's too late, that we're experiencing runaway warming. We are going to, it's yet another mass extinction that we've set off that's unstoppable, and we will all be gone in less than 10 years. There were, players out there, serious protagonists who have pretty large followings who have been spreading that sort of misinformation. So I decided, let's reclaim paleoclimate. Let's look at what the science actually says. And that was the purpose of the book initially, was to address, some of those misconceptions that have been used to feed climate doomism. But in the process, I realized, well, no, there's a whole lot more to talk about. There are all sorts of lessons in, 4 billion plus years of Earth history. Let's see what we can learn from it.
For sure. Before I turn it over to the other guys for questions, I want to talk a little bit more about that doomism concept. It's important to walk a line between urgency and agency, as you like to talk about, but get away from doomism. I'd like to point out, I was actually talking to a Rotary Club earlier today, that there has been progress, right? Clearly there needs to be more, but I like to point out we're starting to phase out coal globally. So there are things going. How do you walk that line in terms of this is important, we need to stay on it, showing that there's progress and not succumbing to doomism for folks who are kind of depressed about it?
Yeah, no, absolutely. And there's sort of two pieces to it. First of all, there's just the science. Like, does the science say that we've triggered unstoppable warming and nothing we do to reduce carbon emissions is going to make a difference? No, it doesn't. And I wanted to make that very clear. And no, the paleoclimate record doesn't support that. The best available science, in fact, tells us now that the planet stops warming up when we stop adding carbon pollution to the atmosphere. So there's this direct and immediate impact, of our on the climate of our efforts to act here. There's another piece to it, though, which is there's another sort of component to doomism, which is like, we're not going to get our act together. And you could argue, that remains to be seen. That's at least arguable. The science doesn't support runaway warming. It doesn't support that sort of side of doomism. But, will we garner the will to tackle this problem? Only the future will tell. But, it's interesting because you mentioned Rotary Club. There are lots of reasons for optimism, lots of reasons, things that we can look at where we can say we're making real progress. Rotarians have really taken a leadership role on this issue. I've spoken to some Rotary Clubs groups in the past, and the youth climate movement, right? I mean, just there is all of this energy. I see it, I teach at the University of Pennsylvania. Climate is probably the number one issue to these students today, to these Gen Zers. Now, some of them fall victim to climate anxiety and climate doomism, so it's really important for them to understand the agency part of that urgency and agency duality. But yeah, the science certainly doesn't support the notion that we can't do something about the climate crisis, and the paleoclimate record certainly doesn't support that either.
Hey, this is Joe, and just want to thank you so much for coming on. Again, we really appreciate it, and best of luck to you and your book here, Our Fragile Moment. My question does partially relate to what you said about, Gen Zers, and, some people do have climate anxiety. And, if you're young, you're impressionable, you're getting content from a variety of different sources, right? More than ever before. But when we talk about extreme weather events and parlaying this into climate change, right? I feel like in the past 5 years, maybe 3 years, we've seen a lot of this recently. And I think personally, from my perspective, it's good. It's always a good teaching moment to talk about the facts and to forecast the climate science. How do you feel, though, about, journalists reporting on this as opposed to meteorologists, who are experts in their field? There's many great journalists all across the country. We know that. But just like I don't know everything about, maybe astronomy, right? journals may not be completely in sync with what's happening, with some of these events. I don't know if you could kind of give us where you fall on this and how you would like to see these extreme weather events being parlayed into coverage as we go forward.
Thanks, Joe. It's a great question. And you were talking about young folks, and I used to think of myself as a young person, and then today I realized that David Lee Roth is 69 years old. So I finally forced to accept the fact that I am now old. But you're right. There is this energy and passion among young folks, and another part of what's going on is we're seeing the impacts of climate change now play out in a profound way in the form of these extreme weather events. And there's always sort of this delicate balance in the way we cover those events. You'll often hear people say, well, you can never blame any one, weather event, on climate change. And the thinking there has evolved quite a bit. We have detection and attribution. We can characterize, how likely an event was to occur in the absence of climate change, and how likely it was to occur when we consider climate change. And when we see that there's a huge increase, when an event was a 1,000-year event without climate change, and it's suddenly, a 10-year event when we include climate change, then we can say, hey, the fact that we saw this is probably because we've warmed up the planet and we've made these sorts of events, these, extreme heat waves, heat domes that we've been reading about, wildfires, floods, superstorms. So there's this scientific machinery now that allows us to sort of characterize the impact that climate change is having on these events. But you're right, when you have trained meteorologists and climate experts who are familiar with that science, they're able to sort of frame it that way. When you have, just sort of, let's say, political journalists, journalists from other fields covering the science, it's a quandary. It's very complicated because they're hearing conflicting things. They're hearing this, you can never blame any one event on climate change, but now they know that that there is a way to try to characterize the impact that climate change is having. So I think there's some confusion among, in the journalistic community right now. You also sometimes see it overplayed, right? Where like every extreme event was caused by climate change. We can't say that. It's like a loading of the dice. Sixes are going to come up anyways. The fact that they're coming up so often is because we've loaded those dice by the warming of the planet. So it is a complicated topic, and it's difficult to even trained, climate and meteorology specialists, even for us, it can be sort of challenging to explain the science and how we're able to quantify the impact climate change is having on these events. And that means that it often gets very confused in the public discourse. And at the same time, I would say that we are seeing the signal of climate change now emerge from the noise in the form of these extreme weather events. And it's a lost opportunity for certain if we don't explain that to the public. And so I personally think that there has been sort of a shift towards journalists in general recognizing that there is a relationship and mentioning that when they talk about these events. Not as often as we might like them to do, but we do see much more of that now. Climate change is part of the conversation here, and that's a real game changer because that's where the rubber hits the road. When people realize, oh man, it's these devastating fires. I have a friend who lost a house, or I have, people I know who got flooded by that storm. When people start to know people who have been impacted or who have been impacted themselves, when people have their own climate story to tell, it really changes the whole conversation. And I think we're seeing that shift.
Hey, Mike, it's Matt. And I think you're right about the climate change, just becoming a term that everyone is familiar with now. But I think the term that people aren't as familiar with, that you mentioned in your book, is paleoclimate. So when you're talking about paleoclimate, how far back are you looking? And what are you looking at to determine what the climate was thousands or millions of years ago?
So it's a matter of perspective, right? If you ask my daughter what's paleoclimate, it'll be, it's like those winters when you were growing up. That's paleoclimate to me. Those 1970s winters. So it's always a matter of perspective. One person's paleoclimate is another person's sort of recent, climate history. I focused a lot of my early work on the last 1,000 years, where we had, we could pull together all sorts of types of information to try to reconstruct in some detail how the climate had changed. But there are, ways to go much further back. There are sediment cores. There are, we can look at ancient oxygen isotopes and reconstruct what ocean temperatures were and what sea levels were. So there's all of this wealth of information. And so what paleoclimate really means, technically it's anything that predates the historical era of the last couple centuries, where we actually have thermometer measurements or rain gauge measurements or what have you. Anything farther back than that, where we have to turn to indirect measures of climate, like tree rings or corals or ice cores, that becomes paleoclimate. And so, 1,000 years, that's paleoclimate, but 1,000,000 years is paleoclimate, and 1,000,000,000 years is paleoclimate. And the stories are so different on these different time scales, and and the puzzles are all different. And each of these intervals, and there are all of these events in Earth's climate history that I talk about in the book, and we can learn something from each of them. Snowball Earth. Yes, the Earth was once entirely covered in ice, and unpacking that tells us a lot about the dynamics of the climate system. The faint early sun. The great Carl Sagan recognized that the Earth should have been frozen 4 billion years ago when life first emerged in the oceans, and we know it wasn't, because there was liquid water, there was life, and he realized, because the sun was only about 70% as bright back then, the Earth should have been frozen, but it wasn't. What's the explanation? How come? There was an even stronger greenhouse effect. And it turns out that gets us into sort of the Gaia hypothesis, because there's this remarkable story where as the sun gradually gets brighter, and the Earth should have got hotter and hotter, but it didn't, because the greenhouse effect got weaker over time. And in just such a way that the planet's climate, with some exceptions like Snowball Earth, stayed within habitable bounds, that are habitable for life. Why is that? That's a really interesting puzzle. And it turns out life itself plays a role in stabilizing the climate, the global carbon cycle, the oxygenation of the atmosphere. There are all of these things that life itself did to change the composition of our atmosphere and to change the dynamics of the planet. And amazingly, life works in such a way as to help keep the climate, Earth's climate, habitable for life. And so that's an interesting puzzle. There's a lot to learn from that as well. And that's a good thing, right? There are stabilizing factors within the climate system. That helps us. There is a certain amount of resilience. And that's one of the arguments against doomism, that we're getting some help from the behavior of Earth's climate. There's a safety, margin. There's a margin where we can perturb the climate and it will stay within habitable bounds. The problem, and what makes this such a fragile moment, is we're now sort of at the edge of that envelope of stability. And if we continue with business as usual, we continue to pollute the atmosphere with carbon pollution, we will leave that moment behind. We will depart from the sort of climate upon which all of this societal infrastructure was built to support, now a global population of more than 8 billion people. And that's the real threat today.
All right, so we're going to take a quick break. We'll come back with a couple more key questions with Michael Mann on the Across the Sky podcast. Stay with us. And we're back with Dr. Michael Mann on the Across the Sky podcast. The new book is Our Fragile Moment. It is a very deep dive, as they say, into paleoclimatology and why this particular moment in time is so crucial in the climate going forward. Mike, your expertise obviously is in paleoclimates and all these things that we use geologically to reconstruct climate. A lot of us are familiar with the ice cores, also these oxygen isotopes. Those, for the weather folks, are not quite as complicated. But what I'd like to talk about a little bit, explain some of the chemistry that's involved that help us tell us what the climate was like when we look at ocean sediment cores. These are things that aren't classic atmospheric proxies, right? These are much more in the rocks geological proxies, those stalagmites, stalactites, those kinds of things. Can you talk about what are we doing with these things in terms of chemistry that tell us what we need to know?
Yeah, so it's amazing. There are these paleothermometers, we sometimes call them. And you think about ice, right? Ice is frozen water, that's H2O. And so there's an O in there. There's oxygen atoms in that ice. And it turns out that the ratio of heavy to light isotopes of oxygen, there are two, main stable isotopes of oxygen, oxygen-16 and oxygen-18. And the ratio of them is a function of the temperature. And when you form precipitation, when you condense water vapor into a droplet, there is what we call a fractionation, where the heavy and the light isotopes behave differently during that process. That's true for evaporation. It's true for condensation. And so if you think about what's going on, an ice core, you're drilling down in the ice, and that ice got there because it snowed at some point. And that snow was condensation of water vapor in the atmosphere. And that water vapor originally came from the evaporation from the ocean surface. And so at each stage, we have what's called a fractionation, where you're getting some sort of separation between the behavior of oxygen-16 and oxygen-18. The bottom line is, because of that, we can say things about ancient sea level from oxygen isotopes in sediment cores. We can say something about temperature from oxygen isotopes in sediment cores. We can say something about temperature from ice in ice cores on land. And it isn't just oxygen. We can look at carbon isotopes, because there's carbon-12 and carbon-13, two different stable isotopes of carbon. And that allows us, for example, to figure out, what happened with carbon dioxide. And what happened with ocean acidification, how much CO2 there was dissolved in the ocean. In fact, if you really want to get into it, we can estimate the pH of the ocean from other isotopes, boron isotopes. And I'm not going to get into the chemistry of that. But the bottom line is there are all of these amazing, we call them proxy data. It's almost like nature provided us a way to solve this puzzle of what happened in the distant past, almost like we were given clues. It's like, well, I'm going to give you these isotopes. And if you're smart, and if you figure out the chemistry and the physics, you will be able to figure out what happened to sea level, what happened to ocean temperatures, what happened to the amount of ice, what happened to the acidity of the ocean. All of these things that are very relevant to how carbon pollution is impacting our environment today.
And Mike, I think we've reached a point now where everybody acknowledges that the climate is changing. It took us a long time to get here, but I think we've reached that point. But what people are pointing out now is that, as you're talking about with paleoclimate, the Earth's climate has changed many times over the years, warming and cooling. So what makes the climate change that we're experiencing now unique compared to the past?
Yeah, it's a great question because, we can certainly find times in the distant past when carbon dioxide levels, greenhouse gas levels, carbon dioxide being the main sort of greenhouse gas that varies over time, they were higher than they are today. And global temperatures were warmer than they are today. During the early Cretaceous period, dinosaurs were wandering the polar regions of the planet. There was no ice on the face of the Earth. We've seen, Earth go from ice-covered to ice-free. So we know there are times when it's been much colder than today, and there are times when it's been considerably warmer than today. So then the question is, all right, well then what makes climate change such a problem? Because, even if we warm the planet with carbon pollution, we're not going to get up to those early Cretaceous levels. Well, actually, if we tried really hard, we could. If we extracted every bit of fossil fuels we could find, we could do that. Why? Because all of that carbon that was in the atmosphere slowly got deposited beneath the surface of the Earth in what we today call fossil fuels. Ancient carbon, organic carbon that got buried in soils or shells that fell to the bottom of the ocean. Carbon that was in the atmosphere got buried beneath the surface of the planet and came down from those very high early Cretaceous levels. Over 100 million years, due to those natural processes, carbon dioxide levels came down. Well, what we're doing now is we're taking all that carbon that got buried over 100 million years beneath the surface, and we're putting it back into the atmosphere, but we're doing it 1,000,000 times faster. We're taking carbon that was buried over 100 million years, and we're putting it back up in the atmosphere over 100 years. And so I sometimes say, if I was going to write a slogan for this, it would be, it's the rate, stupid. We all remember it's the economy, stupid. I think we're old enough. Some of us are old enough to remember that was sort of a political sort of logo. Well, it's the rate, stupid, which is to say, it's not so much how warm the planet is or what the CO2 levels are. It's what climate are you adapted to, and how rapidly are you moving away from that climate? Because we have developed this massive societal infrastructure over, a 6,000-year period. Civilization, I talk about sort of the origins of civilization in Mesopotamia. 6,000 years was the first true civilization. And it turns out global temperatures were remarkably stable for 6, 7, 8,000 years, during which we developed all of this infrastructure that supports 8+ billion people. And we are dependent on the stability of that climate and its ability to continue to support that infrastructure which we've created. And if we're rapidly changing the climate and moving out of that window of variability during which we created civilization, that's a real threat. It will exceed, if the warming exceeds our adaptive capacity, and it exceeds the adaptive capacity of other living things, life has learned to adapt to climate changes that take place over tens of millions of years. That's pretty easy. Adapting to climate changes of similar magnitude that take place over tens of years, that's much more difficult. And again, we have what makes it so fragile, such a fragile moment for us, is that we have leveraged the number of people who can live on this planet, what we call the carrying capacity of the planet. We've probably leveraged it by a factor of 10 through our technology, through our infrastructure. We can support 8+ billion people because we have all of this infrastructure, agricultural infrastructure, engineering. But it's fragile, right? Because if the planet warms dramatically and that infrastructure no longer remains viable, then we can no longer support that elevated carrying capacity. Then we revert to the natural carrying capacity of the planet, which is maybe 1 billion people. And you think about that. The planet without our infrastructure, without our technology, probably can't support more than 1 billion people. We've got more than 8 billion people. That's why we can't afford to destabilize the infrastructure that supports human civilization today. And that's what dramatic warming, that's what unmitigated climate change will do.
Sean said I had the last question here, so I'll wrap up with this. How does studying paleoclimatology and maybe even writing this book make you see our space or our race as humans in this universe? Because a lot of what you're talking about, you said fragile, right? It's the name of the book. How do you see our place in the universe given what you've studied over the decades?
Thanks. It's a great question. And it's something I get into a little bit. I have some fun at one point. We do some thought experiments, like what if there's in one of the chapters, which is on an episode of rapid warming. And by rapid warming, we mean like over 10 or 20,000 years. Rapid on geological timescales, nothing like what we're doing today. But there was this period of relatively rapid warming about 56 million years ago. We call it the PETM. Stands for the Paleocene-Eocene Thermal Maximum. It just rolls right off the tongue. And it was this period during which there was a massive injection of carbon dioxide into the system. Obviously, there weren't SUVs, and there weren't coal-fired power plants. This was a natural input of volcanism through an unusually intense volcanic eruptions centered in Iceland that tapped into a very carbon-rich reservoir and put a very large amount of carbon dioxide into the atmosphere over a relatively short period of time. And so it turns out that, you can ask the question, can we rule out the possibility that there was an intelligent civilization back then that went on this massive fossil fuel burning spree and basically extinguished themselves? And my good friend Gavin Schmidt, who's the director of the NASA Goddard Institute for Space Studies, has written a paper and has written some popular essays about this idea. He calls it the Silurian hypothesis. And it's basically, imagine lizard people who existed 56 million. How can we rule out that that's what happened? And, I grew up watching The Land of the Lost, and Gavin, around the same time, he was in Britain, and I think it was Doctor Who had a similar, that's where the Silurian, there were like these reptilian beings that basically destroyed their environment. And so it's a really interesting question. Can we rule that out? And in the process of trying to rule that out, it actually raises some really interesting questions about, what are the conditions for life? Do intelligent civilizations extinguish themselves naturally? This is sometimes called the Fermi paradox. It was something that Carl Sagan thought about. If the universe is teeming with life, how come we're not hearing from them? How come we're not getting radio signals? And it turns out you can look at all of the different, how many, planetary systems are there in the universe? You can sort of try to do the math and figure out, how many intelligent civilizations you might expect there to be in the universe based on various assumptions. And it turns out the defining problem, all the uncertainty comes down to when intelligent civilizations emerge, how long do they persist for? Do they extinguish themselves? And that would be one explanation of Fermi's paradox. Obviously, it's very personal to us. We don't want to think that we are on our own way to self-caused extinction. So there's some deep questions there. When you look at paleoclimate, you look at some of these past episodes, you can start to ask some larger questions that tap into these deeper philosophical questions about our place in the universe. Is there life elsewhere in the universe? The thinking that you go through turns out to be very relevant to the thinking that you need to go through for these, and the punchline is Adam, now I'm going to draw a blank on his name, he's a well-known astrophysicist and writes about like the search for extraterrestrial life. Adam, and I'm drawing a blank on his last name, which is very embarrassing. I'm sure he'll watch this and be very upset at me. But he actually came to Gavin because he was interested in the search for extraterrestrial life, and asking some questions about climate change and climate change on other planets. And could that explain, why we're not hearing from other, civilizations, because they cause climate change and they extinguish themselves. And Adam Frank is his name. And he's a well-known sort of, science communicator, astrophysics, search for extraterrestrial, sort of continuing the legacy of Carl Sagan and the Planetary Society and the sorts of questions that they were asking. So he came to Gavin, who's a climate modeler, and said, I want to work on climate, figuring out if climate change could have been what caused these other, other potential civilizations elsewhere in the universe to extinguish themselves. And then Gavin says, how do we know that didn't happen on Earth? And they go through this amazing sort of thought experiment. And it turns out it's hard at first blush to rule out that that's what happened. For example, the PETM, it takes quite a bit of work to convince yourself that it couldn't have been ancient lizard people that, burned fossil fuels. And so there's a lot you can learn from what are seemingly silly thought experiments that actually start to get at some pretty deep questions about us and our place in the universe.
Well, not all questions are silly. Plate tectonics has only been around for about 100 years or so, and everybody kind of thought, well, that was silly at the time. Mike, we're going to
remember
let
those
you go.
stickers, Stop Plate Tectonics, bumper stickers? Yeah.
We're going to let you go. But again, the book is our fragile moment. Social media is a mess nowadays, but where's the best place people can find you digitally and online?
Well, they can still find me on, what are we calling it this day? X?
That's what
Twitter?
it's called this week, yeah.
But I've sort of diversified. You can find me pretty much on all of the major social media platforms now. I'm still on Twitter /X and Instagram and Mastodon and Blue Sky, and I'm forgetting Threads. It's like now we've got to be so diversified because we're no longer confident we can rely on the one that we were all relying on for so long. But yeah, I'm out there, and people can find me at www.michaelmann.net. So yeah, it was great talking with you guys, and I hope to do so again.
Mike, appreciate it so much. Take care. Travel safely. Good luck promoting the book. And it's great. I mean, I've read it. It's just wonderful. And also, I will say this publicly. Thanks for the little shout out at the back, my friend.
Thank you, my friend. It was great talking with you guys.
Taking charge of your future starts with taking the first steps. And saving up to $30 a month on Cox Internet with the Affordable Connectivity Program makes those steps easy to take. Whether they bring you to click upload on your first short film, or join now for an online book club. Applying is easy. See if you qualify at cox.com/ACP. Non-transferable one per household. Application and eligibility decisions are made by the FCC.
Those are some very deep answers, guys. You know, where is our place in the universe? And this concept of lizard people from 50 odd million years ago, and the things you will go down, the roads you will go down when you start doing these thought experiments. But for me, the importance here, I think what Mike said is the pace of the warming is without precedent. What we're doing is happening so fast. It is going to be difficult to adapt. Some things are going to adapt more easily than others. And that's why this moment in time is so particular. I mean, yeah, it's been warmer in the past, but our civilization, which is increasingly global, over these last 2,000-3,000 years, in particular the last couple hundred years, where the population has just blossomed, really kind of dependent on the climate that we have out there now. Guys, what do you think? Joe, what did you kind of take away from this, man?
Well, anytime we talk about like our place in the universe, I get really, I don't know, just really focused on the topic, because it does make you think about, in some ways, how small we are relative to everything, and not just even, planet Earth in the speck of the universe, but also human life in the span of the Earth's, long history. And like he also said a few minutes before that question, it's the rate of change of the warming that's unique. I say this a lot of times when I do public talks. I said, listen, yeah, we've been warmer than we've been before. We've been colder than we've been before. But barring like an asteroid or some cataclysmic event, this is the only time we're really changing at such a rate. And there's facts and forecasts, and then there's what to do or not to do about it, and that's where your beliefs come in. But there's no denying that the rate of change, a lot of this, is significant and something we haven't seen really in the scope of human history, and beyond that, the Earth's history, again, minus the early, millions, billion, 2 over years when the Earth was really trying to just get itself together, for lack of a better word, and in some of these asteroid or supervolcano events that happen as well.
I would say this was a humbling conversation, because also at the end, when he was talking about, why haven't we encountered other intelligent life? And then the comment that stood out to me is like, maybe it has existed, but they, because of their actions, resulted in their own extinction. And are we headed down that path? And is that why we haven't encountered intelligent life? And then the other comment that he made is when he was talking about carrying capacity, and now the Earth has a population of 8 billion, but you take out our technology, and what we could see if we continue on this path, if the climate continues at the rate, the change that it's experiencing now, that carrying capacity could drop to 1 billion. And then you think, you think about going from a population of 8 billion people to 1 billion, 7 billion people disappearing, that makes the hair stand on your arms. And to think about, could we result in our own extinction by our actions? And when you hear that, you want to say, let's not make that mistake. Let's do something about this. Because again, the other comment was, it's the rate, stupid. And he talks about, yes, climate has changed in the past. And that's what some people keep coming out. It's like, well, what's the big deal? If the climate has changed in the past, we're just going through another cycle. But it's never changed at this pace. And we can't keep up. He also talked about the acting of the planet has taken care of itself. When the sun became stronger, the greenhouse effect decreased. And so there has been that the earth has all these protections in place to kind of keep the climate in balance. But we're breaking that. We're breaking these natural protections. That's why he calls it our fragile moment. Because if we continue at this pace, the earth isn't going to be able to heal itself. And so we have to take action to make sure we don't lose 7 billion people. Again, we don't want to talk about the doomism. So it's a fine balance, though, because we absolutely have to take action. But know that we can take action. This is not hopeless. We still have time to fix this problem. So let's get on it.
Yeah, as he says, there is urgency, but there is also agency. So I think that's the quote that I like from him most of all. So as we look to some other episodes coming down the pike, a little bit less heady. Coming up next week, we've got Paul James of HGTV. We're going to look at the science of changing leaves. We are thick in the into the fall right now. The leaves changing from north to south across the country. And we're also working in the background to bring you a broader winter forecast. We're still turning a couple of knobs on that, but we're working on that. I'll be talking to Neil deGrasse Tyson in a few weeks. We'll bring that to the podcast. Also, I've talked to a couple of colleagues, the 5th National Climate Assessment's coming out. And we're going to say, well, what does that mean and why should we care? We'll answer those questions. And we've got one more, Joe. You've got somebody coming in from Ohio State, right?
Yeah, we do. That's coming up in a couple of weeks. That's for your November 6th episode. We're speaking with Dr. Lauren Sutherland. And it's tips to prepare older loved ones in case of natural disasters or extreme weather. I've covered this topic a number of times for the Press of Atlantic City, where I'm based out of. Shout out to everybody listening, Jersey. But talking about some of the challenges, our senior citizens are having when there are these kind of extreme weather events. So that should be really good. I'm looking forward to that one too. And that one comes out on November. So
we have got a lot of good stuff in the pipeline in the weeks ahead. But for now, we're going to close up shop. So for Joe Martucci at the Jersey Shore, Matt Holiner in Chicagoland, I'm meteorologist Sean Sublette at the Richmond Times-Dispatch. We'll talk with you next time. Thanks for listening to the Across the Sky podcast.